All right, welcome to Git and GitHub 101. Let's first take a look at what is Git. What is Git? And let's see what the internet thinks Git is. Of course. Git is a mature, actively maintained open source project originally developed in 2005 by Linus Torvalds, who, fun fact, also created Linux. The famous creator of Linux operating system kernel. That is not helpful whatsoever. So essentially, Git is a way for you to write a bunch of code and then for me to take a look at that code and maybe add a little bit more to it so that it's a collaboration tool. It's also a version control tool, which means at any point in time, if you wanted to, you could write some code today, write some code tomorrow, write some code the day after, and then you can come back in time and you can see exactly what code you wrote today. And so you don't have to like Control Z or Command Z and undo a bunch of stuff. You can literally just hop around from the current code to the old code. And so it allows you to see what kind of mistakes you made or to fix mistakes, or if you produced a mistake, you could go back in time to before that mistake or that bug was introduced. That is what Git does. That is what Git is. It is a version control system and a programming collaboration tool. What is GitHub? Okay, so GitHub is a way for you to use Git on your computer, and then it is a user interface in the form of a website where you can actually go and take a look at all the different code. And so, for example, if we take a look at Wagtail, this is basically what GitHub looks like. So it's not glorious by any means. It's not the fanciest looking thing out there, but it does allow you to see everything, all the code. And so this is an open source project called Wagtail. And if I wanted to, I could look at any of the code from really any contributor, or I can take a look at the 10,741 commits as of today. That's how many pieces of, not pieces, but how many updates there have been in the Wagtail project. And I could go back and I can take a look at any one of these updates from anybody who made those updates. So we can see the latest one here is from January 13, 2021. Fix formatting in development documentation, and that's from David and Thibaut. Thibaut is on the core team there. We could go back and we could see, let's see what happened here. We can actually see that a line was deleted and a line was added. This is what was deleted and this is what was added. And so this is called version control. And this allows you to see the different changes that other people have introduced. And it allows you to wrap permissions around who can add what into your code base, or if you can add certain things into other people's code bases. And GitHub.com is the way we basically use Git. Now, you don't have to use GitHub.com. You can actually do it all through your command line if you want to, but most people prefer to use GitHub.com just because it comes with a nice user interface. Now, this might look a little bit daunting at first, but we're going to go through a lot of what all of this is in this course. All right, for this course, you are going to need to have a free GitHub account. Now, GitHub is completely free. There is a way that you can pay them and you can get some extra features, but honestly, for the most part, it's just free and all we need is free. I've never paid for GitHub and I've really used it a lot in the last about 8-9 years or so, somewhere around there. So to sign up, all you have to do is go to github.com, click on sign up, create a new username, enter your email address and your password. It will then verify your account. Pick the dice, pair adding up to 7. Oh, this is pretty cool. Okay, so you just fill that out and then you create a new account. Now, I already have an account, so I'm not going to do that. You might need to verify your email address as well, so make sure you put the right email address in there. We're also going to need to know what that email address is down the road when we set up Git on our computers. So make sure you are familiar with your username and your email address. Once you are logged in, you should see a page something like this. Your page might be considerably more empty than mine. I have a bunch of feed activity in here. You can think of GitHub as a coding social network to some degree. You might not have repositories or teams on the left, and that's totally okay. If you have a brand new GitHub account, that is totally okay. Over time, you will start building these up. So once you're in here, we're going to need to find a demo repository to look at, and because we're going to need to know what a repository is. We use this word all the time, and so in the next lesson, let's take a look at what a repository is. Okay, what is a repository? So if I jump here and I just type in Wagtail, I'm going to see that I can go to github.com/wagtail, that's the organization or the account, and that is the project name as well. And so all this code that you see in here, this is part of what's called a repository, or a repo for short. And so this repository tells you all the code that's in here. You can see literally all the code. You can even see code from years and years ago. We can see that there are 747 issues. There are 161 pull requests pending. We'll talk about those down the road. You don't have to worry about what those are right now. And that there were over 10,000 little updates to this repo in the form of a commit. It's called a commit, and it's just a tiny, tiny little update. And so every repo is going to have a bunch of code, and it might have different code depending on which repo you're looking at. So this one is a Python-based repository, and we can see that even in the languages here, Python takes up 81.9%, HTML is 9%, JavaScript is less than 5%, Sass is less than 4%, TypeScript is less than 1%, Shell is less than 0.1%, or is 0.1%, and a bunch of other things that take up 0.1%. And so you can see this is primarily a Python repository. If we scroll on down, we're going to see this thing called a README file, and these are the instructions that you're going to see in a repo. Now let's go ahead and take a look at another repository. Let's go to Coding for Everybody. Oh, that's looking inside this repo. We want to look all of GitHub. And just go down to Users and then click Coding for Everybody, and you can see all the repositories in this organization. This is an organization. This is a profile account called Coding for Everybody. There are 7 different repositories in here that you can see. And let's go to 7 Days of Wagtail. This is the newest one in here. And you can see all the code in here. You can see that there's only 2 commits. There's only been 2 updates, the final source code and a README. And we can even go in here and we can see what was actually changed. And so green means something was added, red means something was deleted. And there is no red, so nothing was deleted. Just this README file was added. We'll talk more about commits and issues and pull requests and all that stuff down the road. But for now, you just need to be familiar with what a repository is. So a repository, or a repo, is basically a bunch of code for your project that lives on GitHub in some sort of decentralized area. So GitHub, GitLab, Bitbucket, something like that. What is a README file? So a README file is a specifically named file called README, in all caps, readme.md. That stands for Markdown. And the idea here is it's usually an introduction into what the project is, and maybe some installation instructions as well, maybe some notes on how to contribute as well. There can be pretty much anything in here, but the idea is that a README is simply a Markdown file that allows you to give instructions for your repository. And so most repositories have a README file, and the idea, again, is just to let people know what your project is about. Without a README file, people are not going to look at your project whatsoever. They're just going to say, hey, there's no README file, I'm not going to even take a look. And if there's no README file, this section down here is simply not going to exist. So if we go ahead and click Edit, just because I control the Coding for Everybody organization, I'm able to edit this. This is what a README file looks like, or at least a Markdown file. And so we've got a title, we have a quote, we have an H3, another H3, so a smaller title, not the smallest, but a smaller title. What else do we have in here? We've got another quote, we have some bold in here, and a link, even an emoji, and if we wanted to, we could always preview the changes as well. And this will just show us, this is what we wrote, and this is how it turns out. And so that is a README file. Now, I don't actually want to do anything with this README file, because I'm happy with the way that it is right now. The nice thing about a README file is that it comes in the form of Markdown, and that's what we saw with those number signs or with quotes and things like that, is it is a very simple way to write. Basically, it's almost like writing code, like you're writing HTML. But the idea is that you can write very, very simple headers and you don't have to worry about knowing HTML. You can just write number sign and then whatever your text is going to be for your title. And it's automatically going to make it linkable for you. It's automatically going to make this large for you. That is the nice thing about a markdown file. Let's go ahead and take a look at that one more time. So we have 7 Days of a Wagtail. It's a free course. And that is a title. Let's go ahead and copy this whole thing, but let's do 2 number signs. This is the difference. So the green means that it's new. It just showed up. So we don't have to worry about that actually showing up in there. That's just telling us that that's new. This was the original, and this is a smaller one, and this is an even smaller heading. And so again, the nice thing here is we don't need to know HTML or any other programming language. We can literally just type number sign, and create a small title. Or we can create a large title with just 1 number sign, or a small-ish title with 3, or a really small one with 4 or 5 number signs in front of it. Anyways, this is not a lesson on Markdown itself, but this is a lesson on what a README file is. And so when you have a README file, it's going to automatically show up in here. If you don't have a README file, it's not going to show up in there. So just keep that in mind because we're going to be using that in the future. Just tuck that in your back pocket for now. You don't need to know how to create a README or a Markdown file at this moment, but you will need to know how to do that in the future. It might take a little bit of research, which is totally fine. But for now, you don't need to worry about what all this is. I just wanted to show you that, hey, if there is in fact a readme.md file, it will show up. It will automatically render in your repository by default. What are commits? So when you have a repository like this, you can have, and by the way, I'm looking at wagtail/wagtail. When you have a repository like this, you have a lot of different contributors and a lot of different people trying to write code and trying to make your code better. It's essentially what open source is all about, is trying to make everybody's code as good as it possibly can be, especially if you have an interest in someone else's code. Now, every time someone writes a little bit of code on their computer, packages it up and puts it on GitHub, that is called a commit. And so a commit is basically a small little update to a larger repository, and there can be an unlimited number of commits. And so we can see in the Wagtail repo here, there are over 10,000 commits already. That means there's over 10,000 small little updates. Now, they might not all be small. There might be some really, really big ones in there. Who knows? We could go through all of them and take a look if we wanted to. And in fact, yeah, let's actually do that. So on GitHub, what you can do is you can just click that commits, and you can go through all of the commits through all of time. So let's just click older. All the way down. We can go older and older and older. And older, and we can just keep on going. So let's take a look at this. So Carl and Thibaut, who are both on the Wagtail core team, did a bunch of work on October 21st, 2020. Let's take a look at what the update Webpack work was. And so now I'm looking at a specific commit. This is specifically what they wrote on their computers, and they pushed it up to GitHub. And so we can see here that in this commit, we have exposed loader is version 0.7.4, and that was actually bumped up to 0.7.5. Webpack was bumped up to 4.43 from 3.10. And we added Webpack CLI. What else did we do in here? Webpack dev watch command is now going to do -- mode development -- progress -- watch. That's brand new. And something similar for Webpack prod build command. Now on every commit, I could always leave a comment. I could say, hey, this is really great. Love what you're doing. Thank you for doing this. Or I could leave a little comment on here and I could say, hey, by the way, I think you should add another flag in here, another -- something or other. If you're familiar with Webpack or whatever the commit is about, you could add some feedback in there as well. There's another way to look at commits as well. You can do the unified way. I personally like the split way, but some people prefer the unified way. So split is things deleted on the left, things added on the right. Unified is things deleted above and things added below. So we deleted this line, added this line, deleted this line, added these two lines. And so again, the idea here is that this little piece of code was added to the main Wagtail project, the whole repository, and it wasn't actually a lot of code. It was just a few lines being changed. And that's a really good example of what a commit can be. A commit can be literally one letter. It just needs to be one character changed. That's it. Or it can be a massive, massive commit. It can be something huge, hundreds and hundreds of lines. Now, it's usually better if they're smaller so that someone else can review your code. We'll talk about that in pull requests way down the road. But for now, what you need to know is commits are a way for you to travel through a project's history to see code at a different point in time. So for instance, we could go to January 5th, and we could browse this repository at this point in history. This is the code from January 5th. All of it. This has nothing after January 5th. Oh, and one more thing is every commit has this thing called a hash. So let's take a random commit here from Gasman, Matt Westcott here. And let's just copy that. And let's throw this up in the URL and paste that. This is the commit hash. Every commit has a unique hash, and you use this to basically look at code from a different point in time. And we can do that through our command line using Git on our computers, which we don't have installed yet, and that's totally okay. We will get there. Or you can look through the repository at a certain point in time using this hash. And you can see this hash shows up the first, 7 characters? Because that's most likely going to be the most unique identifier. We have, I don't know what that is, 32, I'm guessing, characters? Versus just the first 7. The first 7 is usually unique enough for us to identify a commit by. But if I click this, you can see that that hash is in my URL up here. And we can actually see all the things that have changed. So that is what a commit is. A commit is a way to travel through time, to see little code updates. And how it works is basically you write a little bit of code on your computer, you package it up, and you mail it over to github.com. Electronically, of course. We mail it electronically through a program called Git. Okay, let's take a look at what stars are in Git and GitHub. So I'm on github.com/wagtail/wagtail, Wagtail being the organization, and Wagtail being the repository name. It just happens to be their name, the same thing. It's a very common thing. You'll see that a lot in GitHub, on GitHub rather. And in the top right, we have a few different options here. So we've got fork, unstar, or yours might say star, and watch or unwatch. And it's going to be a little bit different for you. So I'm already watching this repository, and I have some custom settings in here. And I'm already starring this repository. Let's go ahead and find a repository that I might not have been watching and might not have starred already. Wagtail Factories. Nope, I'm already watching. Let's go to Condense Inline Panel. Here we go. This is one that I haven't actually really worked with too much. And so it's saying that I can watch, and you can click here and you can see who's watching it. And watching is just like when something happens, that person will get a notification. And it can be completely ignored. They'll never get notifications. It can be custom. But this lesson, we're talking about stars. And so the idea here is a star is like when you're on Instagram and you like a photo, you get that little heart that pops up. That's a star. When you're on Facebook and you like someone's post, that's a star on GitHub. When you're on Twitter and you like someone's tweet and that little heart shows up, that's the equivalent of a star on GitHub. I think you get the point now. And so the idea here is that we have these things called stars and stargazers. And so every repository gets stars. And you can see who has starred a repository, just like any social network out there. And if you wanted to, you can simply click star to show your support. Now, if you're ever working with a repository and you're like, hey, yes, I really, really like this repository. This has been really helpful. Please, please star it. A lot of people will put in a lot of effort into open source projects, and a lot of other people will look at that open source project and see, oh, it only has 5 stars. I'm not going to use it. I'm going to use something that's a little more popular. But it could, for all we know, be extremely popular amongst stargazers. They just haven't clicked that star button. And so a stargazer is anyone who has starred a repository. When we're dealing with Git and GitHub, or Git and GitLab, or Git and Bitbucket, really any other sort of user interface for version control, such as GitHub, we have these things called reviews. And so the idea is that someone can write some code, and someone else can then review it before it gets merged in. Now, we're not going to talk about merging or pull requests, not yet anyways, but the idea is that, for instance, we can go to pull requests. I can go take a look at any given pull request. I can see the files changed in here, and this is basically code that's being asked to go into the main repository. It's not in there yet. And I can review some of this code. So I can say something like, this is a blank line. It's not needed. And then I could start a review if I wanted to. Or I can add a single comment, or I can cancel. And yes, I want to discard my changes because I don't actually want to leave that comment. And so the idea here is that someone can review. So Gasman has asked Carl here to review his code. And so Carl's going to then go through here and say, oh, yep, okay, everything looks okay, things look good. And he's literally just going to read through this code. He's going to go dom.find, find a bunch of stuff, .click, JavaScript fat arrow, or JavaScript arrow function. In PHP is a fat arrow. In JavaScript, it's just called an arrow function. So click arrow function, if yada, 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 a bunch of stuff in there. And if everything is good, he's going to approve it, or he's going to just leave a comment or request changes. And so the idea here is that you have peer review. And so programmers, we like to think we're smart, but honestly, we're not so smart that we write perfect code. And so we get another human to look at our imperfect code to try to make it as good as possible, or at least good enough. And that's what a review is. Now, we're going to look at those a little bit more in the future. I just wanted to show you that that's what a review is. What code should you open source? That is a great question. So when we create a new repository, and we will create a new repository, I'm just going to show you here just as a glimpse into the future. We can have a public repository so everyone can see our code, or a private repository where only we can see our code. And there's a use case for both of these. So if I go over to my account, github.com/Caleb Tallien, and just go into my repositories. Oh, I have 54 repositories. That's quite a bit. You can see that I actually have a repository already. It's the first one that shows up. It's private. It's just called school. And then I have some other ones that are completely public. So like Git Essentials, which is what your project is going to be in Git and GitHub 201, I believe. There's Django 201, so the source code for Django 201. We could go and see all of the commits in here. This is all the step-by-step instructions for the Django 201 module. And so the idea that I want to talk about in this lesson is, what code should you open source? And so in my opinion, open source as much as possible. The world has thrived off of open source, and you wouldn't believe it, but almost everything comes from open source. Almost every website you hit, every website that you use is using Linux behind the scenes, completely open source, 100% free. If you write Django, like I do, completely open source, 100% free. And so the idea is to perpetuate or to move that momentum forward by creating more open source stuff. And so pretty much any project that you have, I would say make open source if you can. The other question I guess we should tackle is, what should you make private? And so I'm working on a project, codename School, and I don't want it to be public. I don't want everyone to see the source code. I want it to be a little more proprietary. And the idea is I'm going to be building a company around this. And I don't want other people being able to steal that code. I want to be able to create a for-profit business using this code in here. But, for example, Git Essentials is completely open source. There's 26 commits in here, and it's completely available. You can see all the commits, you can see everyone who's contributed, you can see all the different pull requests, you can see all the different issues, you can see all different things in here. And so when you're going to work on a project, I would highly, highly, highly recommend that you make it open source. Just because primarily when you go and look for a job, someone who is interviewing you is surely going to Google your name. And if they can find you on GitHub and see that you A, can use Git, B, can use GitHub, C, know how to open source code, that is a strong indicator to them that you are a decent developer and that they should in fact take you seriously. So I would say open source as much as humanly possible. There are cases where you don't want to open source, but for the most part, pretty much all of my code is open source. I have very few things in here that are private. I've got a client, Presidential Auto, private. They paid for that. The repository for learnwagtail.com, it's a security thing. It's private, but everything else is public. And so you can see most of my stuff is public. It's all open source. Downloading and installing Git on your computer using Windows. So let's type into the old Google machine, how to download Git for Windows. And I'm on a Mac, so I can't actually go too far with this, but I can show you what I will recommend. So there's a lot of stuff in here, but there's actually one particular tool that I really like, and it's called gitforwindows.org. And the idea here is you can run all of your regular Git commands on Windows, because Windows does things a little bit differently from Mac and Linux. You can run all of your Windows commands just like you normally would with Mac or Linux. And so you go to gitforwindows.org, click on download. And chances are, if you have a new version of Windows, you're going to want to download Git 2.30 64bit.exe. And so let's just scroll on down and let's find, which one are we looking for here? Git 2.30.0.2 64-bit, not tar. If you're on Windows, you probably just want the .exe file, and that will automatically allow you to install it with a click of a button. So if you're on Windows, go ahead, download this, install it, and whenever we write commands using Git, we're going to be using this program called Git for Windows. Not PowerShell, not command. We're going to be using this particular program. And that's just going to keep things nice and succinct for all of the students taking this course. So whether you're on Windows or Mac or Linux, if you use this program, all of your commands are going to be the exact same and they will magically just work. So as a recap, for Windows users, go to gitforwindows.org, click on download. It will bring you to this page. Look at that. It actually brings you to a github.com page. That's pretty amazing. This is open source. And then download the version that's most applicable to you, either 64-bit. If you have, let's say, Windows 10, chances are you have 64-bit. If you're running on Windows 7, you might need the 32-bit one, but chances are you're going to use the 64-bit one. Scroll on down. Download the .exe file, whichever one is the appropriate one for you. Install it, and when you're ready, let's head on over to that next lesson. Downloading and installing Git on your computer for Mac OS. So let's do this. How to download and install Git for Mac OS. I'm just going to type that into Google. And Atlassian, not really sure how to say that name, to be honest. Huge company out of Australia, though. Has some good, helpful articles here. And so this one, it says installing Git on Mac OS X. And so if you already have Git on your computer, what you can do is you can open up this program called Terminal. And I'm going to make this way bigger. And you can type git -- version. And you can see that I have Git version 2.23. You might not have that already. You might have nothing. And if you don't have Git in there, if that command does not work for you, what you can do is you can download the latest Git for Mac installer. And so I just click this link, and this is going to bring me to sourceforge.net. And all you have to do is download the latest version. Make sure you download and install that. It's a DMG file, so make sure you actually install that properly on Mac. Once you have that installed, what you can do is you can open up your terminal. What I like to do is I like to close my terminal entirely, and then I just reopen it, and that just sort of refreshes things for me. And what I can do again is, if I just zoom in here, you should be able to do git -- version. Once again, you're going to need to install that installer, or you're going to need to execute that installer. And so that comes from sourceforge.net. All right, let's talk about how we can download and install Git on your computer on Linux. And so this is really, really different for a lot of different Linux flavors. It really depends on the version of Linux that you're using. Chances are you're probably using Arch or Arc. I've heard people say it both ways, or Ubuntu. Now that may not be entirely true for everybody, but for most people, they're going to be using Arch or Ubuntu. And so what we can type into Google is how to download and install Git for Linux. And let's just go straight to gitscm.com. And this is going to tell us exactly how to install Git on Linux. Installing Git on Linux, sudo apt install git-all. If you're on a Debian-based distribution, such as Ubuntu, try using apt. And so that's really all you have to do, is just follow these instructions in here. And that will install it for you. And then you can do git -- version, and that should show you the version of Git that you're using. Okay, let's talk about how we can configure your Git user name and email. And so once you have Git installed and it's running on your computer, and the idea here again is that you can do, if I just make this significantly bigger here, if I do git -- version, I can see that I'm using Git. It shows me a proper version. I should be able to type git config, and remember, if you're on Windows, you're going to want to open up Git for Windows, not your regular terminal, but just Git for Windows. And it should show you all sorts of stuff in there. Now, we're not going to read through all of that because that's going to take like an hour probably. But what we are going to do is we're going to configure our global username and our global email address. Now, if I just flip on back here to this Atlassian article, configure your username and email using the following commands. Replace Emma's name with your own. These details will be associated with any commits that you create. And so the idea here is that when you package up a little bit of code on your computer and you ship it off to github.com, who is it going to say it's from? And so what we want to do here is type git config -- global user.name, and then in what looks like a string or in quotations, I would say Caleb Tallien, and this is going to be my name, just my regular name. Now that's already set up on my computer, so I'm going to skip that, but you would hit enter. And then we need to configure one more thing. So git config -- global user.email, and this email address should match the email address that you use to sign up with on github.com. For me, that's caleb.tallien@gmail.com. And then you just hit enter and away you go. Now the way you can confirm that is you can type, now if you know what you're doing on the command line, you can open up a file. So I'm going to use cat just to print out the file, and I can do home git config or .git config, and it's going to show me in here user, name, and email address. I have a bunch of other stuff which we'll talk about in the future, in a future Git course. But for now, this is what you need to see in your git config if you have a git config. All right, let's go ahead and create our first Git repository. And so what we want to do here is go to github.com, make sure you're logged in, and click this little plus over here and click new repository. I'm just going to call this test repository. And this may or may not exist at the end of this course. I might actually just delete this, but I just want you to sort of follow along with me. So create a repository in your account called test repository. This is a test description. I'm going to make this public so that it's open source so anyone can see it. I want to add a README file. I want to add a gitignore file, the gitignore template. Let's say I'm going to be working with Python. I'm going to select Python in there, so it's going to ignore PyCache files, PYC files, all sorts of things that I don't want to commit to a project. And let's choose a license. And let's choose the MIT license. It doesn't really matter. I'm just doing this for demonstration purposes. Now let's go ahead and click this repository, create repository. And this is going to go ahead and create a new repository with files in here. Now, that's really all there is to creating a brand new repository on github.com, but this does not exist on our computer. So we needed to make it exist on our computer. So we click this button here, code, and we can see the HTTPS, SSH, or GitHub CLI. Let's click on the HTTPS one. And this is just going to give us this link, https github.com/calebtallien/test-repository.git. Let's go ahead and copy that. And let's go ahead in our terminal or command line or whatever program you want to use, PowerShell, Bash, terminal, iterm2. It doesn't really matter as long as you have a command line program. You could even open this up in VS Code if you wanted to. Just open up the terminal in VS Code. We want to mkdir test dir cd test dir, and you should already be familiar with how to move around on the command line. This is really, really important when using Git. Now there's two ways to learn Git. There's the user interface way, where everything is graphical and right in front of your eyes, and there's the command line way. In command line way, command line interface, CLI, is harder. And the way I'm teaching you, I'm purposely teaching you the harder way, because when you're on a server and you want to get the latest code from your repository, there's no visual interface. It's all command line. And so I'm setting you up for success by teaching you the hard way right now. So I'm inside of my test directory, and what I can do here is I just copied this over. I can type this command, git clone, and then just paste that. And if I do ls-la, or if you're on Windows, you can type dir. It has a new repository in here called test repository. So let's cd test repository, ls-la. And you can see we've got a folder called .git, a .gitignore file, a license file, and a readme.md file. Let's go ahead and open this up in VS Code. And you can see here, if I just make this a touch bigger, that we have our gitignore, our license, and our readme. And that is all coming from and came from our repository here. Now again, that command that we typed was git clone, and we just pasted that URL in there, the one that GitHub told us to copy. In the next lesson, let's go ahead and edit one of these files so that we can start to package it up and put it on GitHub. Because right now, all we did was on GitHub, over here, in the right browser, we have .gitignore, license, and readme.md. We didn't actually edit these files, but we did download them from GitHub and put them on our computer. Now we need to do the reverse. We need to edit a file on our computer and push it back up to github.com. And it's actually called a push, but we'll talk about that in a little bit. All right, let's go ahead and edit a file on our computer. And so what I did was code dot in my folder, and it just opened up VS Code for me. Now you may or may not have that installed. You might have to go into File, Open, and then open up your whole project using VS Code that way. Either way, that's fine. So let's go ahead and open up this README file, and let's just make this a touch bigger. And this README file just says test repository. This is a test description. Underneath, let's say this is a new edit from my local computer. And so a local is always your computer. Your computer is always local. And when we're editing websites, or when we're working with websites on our computer, we always use localhost. And so this is from our local computer, and github.com is called a remote. So let's go ahead and save that. And if we go back to our terminal here, we can do a git status, and this is going to show me a file in red. And this file in red says that it was modified. So what I can do here is, because it was modified, I can say git diff, type in readme. Remember, it's case sensitive, so it's all uppercase readme dot lowercase md. Git diff, and this shows me that there is a new empty line here. It's green, and this is a new edit for my local computer. This is what I wrote in here. Now I have Git installed on VS Code, so you can see that these are two new lines as well. But on the command line, it simply looks like this. So what we can do again is git status, and that shows us the status, shows us unchanged files, new files, things like that. We can simply do git add readme.md. And this is going to change the way it looks when we type git status again. And so what we did here is we said we staged this for, basically think of it like you're mailing a letter. What we did here was we put our letter inside of an envelope. We haven't mailed it yet. We haven't gone and dropped it off in the mailbox. We haven't sent it to the post office yet. We have simply put it in an envelope. We need to say who this is to and what the message is about. Like, what is this letter actually about? And in the next lesson, what we're going to do is we are going to give this a little bit of a message. So we're going to sign our letter. We're going to say who it's to, and then we're going to possibly send it off to GitHub so that they can update our code for us. Okay, in the last lesson, what we did was we edited our readme.md file. And in my command line, if I do git status, I can see that I have a file. It was modified. It was readme.md that was modified. So I can do git diff readme.md, and I can see that these are the changes in here. Modified readme.md. Green is the things that we added. Let's go ahead and actually delete a line in here as well. So I can do git status, git diff readme.md, and you can see red means I deleted it. Green means I added something. And so what we want to do is, if we do git status again, and it's okay to type git status a million times, git add readme, and this is going to turn it green. And this is ready for, it's ready for us to mail it to github.com. And so this is called staging. And what we did here was we staged this file, said, hey, this is ready to be packaged up in a thing called a commit, and it's ready to be sent to GitHub. So if I just clear this off, do git status again, we can see that this is staged. And I can do git commit -m for message. Let's say updated the readme file. And I put that in quotations. And now if I do git status again, you should see nothing in there. Absolutely nothing. But if I do git log --1 line, this is our initial commit. This is when we downloaded code from GitHub. And this is the updated README file. That's our latest commit. Now, head is where our Git is pointing at. Origin main is GitHub. It's where origin thinks it's at. Origin head thinks it is at here. And so what we're seeing here is that our computer, our head, is on this commit. GitHub's head, origin head, is on initial commit. So if I go back to github.com and just refresh, we're going to see that my code didn't do anything. It didn't make it to GitHub yet. What we have to do is we have to push this code to GitHub. And that's what we're going to do in the next lesson. But right now, all we did was that git commit -m some message after we staged a file. And if we do git log --1 line, we can see that we are ahead of the code on github.com. And we need to basically tell GitHub to come and download our code from here. Or the other way around, we're going to push our code to GitHub. We're going to do that in the next lesson. Okay, let's take a look at how we can push our files to our github.com repository. So in the last couple of lessons, what we did, just to recap, was we edited a file. Then we said git status, it was red. We did git add whatever that red file name was, so readme.md. And that was staged. Then we committed that file, and that message is basically like signing your envelope, saying, what is the purpose of this letter? What is the purpose of this code? And so we said, do a thing or something like that. And that's basically where we're at right now. So if we do git log --1 line, we're going to see this is where our code is at. Our GitHub program, our head, is at main, and it's on this commit. It is one commit ahead of this one. GitHub's head, GitHub's program called Git, the one that they run behind the scenes, that's called origin/head, is at initial commit. And we need to basically say, hey, GitHub, we want you to have this new code. And so the way we do that is we do git push origin main. Now on older repositories, it's called master. On newer repositories, it's called main. And to figure out which one is which, if you go back to your repo, if you see up here, it'll just say main or master. If it says master, you type git push origin master. If it says main, you do git push origin main. So I'm going to do git push origin main. It's going to ask me for my username, Caleb Tallien. And when you run this, you should hopefully not see invalid username or password. I have extra security set up on my account, so I simply can't do this the same way you do, but you should simply be able to put your username and password in there, and that will authenticate you. And so what you should see is this: enumerating objects, a bunch of stuff, counting objects, delta compression, compression objects, compressing objects, a bunch of stuff that we don't really understand. And it's going to github.com, my account, test repository.git. And so if I go back here to my repository and hit refresh, what you're going to see is now there are two commits. There's one called initial commit, and there's one called updated the readme file. And that's the one we added just a couple of lessons ago, updated that readme file. And so that's what that commit message is. That commit message is exactly what we wrote. And this is exactly what we saw when we wrote git diff readme.md. We deleted a line and we added two new lines, one blank line and a new line that says this is a new edit for my local computer. And that's how we push files to a GitHub repository. Let's do one more example here. Let's go ahead and delete this and say this is a second example. And we're just going to edit that readme file. And again, the reason we're doing that readme file is because if we go back to that code, it shows up automatically right in here. And so I save this file, open up my terminal, I can do clear git status. I see that it's been modified. Git diff readme.md. I can see that I deleted a line and I deleted this red line and I added this green line. So git status once more. I can git add that readme file. And remember, this simply stages it. When it's green, it's staged. And you can tell that it's staged. It says changes to be committed. And if I want to unstage, we can say git restore -- stage and then the file name. We don't want to do that. We want to send this to GitHub. So this is staged. It's ready to be committed. So this is like being in an envelope. We just need to sign this envelope now. Second update. That's what we're going to put on here. Now that's great, but if we do git log -- one line, we're going to see that we are now ahead of where GitHub thinks we are. GitHub no longer thinks we're at initial commit. We did a push a little bit earlier, and so GitHub thinks we're at updated the readme file, or #7bbd9cf. But our local code, our code on our computer, is one step ahead. And so to basically push this code to GitHub, so GitHub is also up on main, we can do git push origin main. And for you, it's probably going to ask you for your username and password. That's okay. It's safe to put your username and password in there. That's your GitHub username and password. And last but not least, if we do git log -- one line, we can see in here, origin head is at second update, main or origin/main is at second update, and our local computer is at second update. So we're all up to date now. And what we can do is we can go back to Firefox or whatever browser you're using, hit refresh, and we have 3 commits now. Second update shows up, and it's exactly what we wrote. This matches our computer. And I'm going to go to the split view here. And so we deleted these red lines, and we added this green line. And that's exactly what we have here. This is a second example. This is a second example. And if you're ever wondering, oh, is that actually where it's supposed to be? You can always just click on code and go to the main code base, and it's going to say this is a second example. Okay, let's take a look at how you can download the latest files from your repository. So you can actually edit files directly on GitHub. And so let's go ahead and click this little edit icon, and we can change this directly on GitHub. And so let's go ahead and change this from test repository to my very first repo. And let's say Caleb is an awesome teacher. I will leave him a nice review? Question mark? Hopefully that's true. I'm gonna go with it. I'm gonna say I hope it's true. Click on preview changes, and it shows you the stuff on top, deleted, it's red on the side, so we know it's deleted. It's green on the side down here, so we know it was added. And we need to commit our changes. And so this is just like using the command line, only we're doing it through the website this time. Updated the README for a third time. And that's all I'm going to do. You can add an extended description if you want to. This doesn't really require a long description. This just requires a standard commit message. So let's go ahead and commit directly to the main branch and commit changes. And so let's go back to our main code base here, and we can see that that updated. We have 4 commits in here, and the very last commit said updated the README for a third time. So we did that right on GitHub. Now, the problem with that is if we open up our terminal or Git for Windows and we do git log -- one line, our computer thinks that Git is exactly where we are at, which is not true. We need to pull in these latest changes. And so there's changes on github.com that are not on our computer, and we need to go and get those. And it's really easy to get those. What we can do is we can do git pull. So before we were doing a push, this time we're doing a pull. So we git pull origin, and that origin is going to be github.com. Or if you're using GitLab, it's going to be gitlab.com. Or if you're using Bitbucket, it's going to be bitbucket.com. But we always just say origin. So git pull origin, and then our branch name. And that branch name comes from here. So we're using main. If you're using an old repository, it might be called master. So we're going to git pull origin main. And this might ask you for your username and password. If it does, you can put your username and password in there. And otherwise, we have downloaded the latest source code. So what we can do now is we can git log -- one line. And that second update, we're no longer on that second update. We are on updated the README for a third time. And so now our local computer says, oh yeah, we know that GitHub is at this particular commit message. And so are we. And so if we go back to our code, in my README, it says, my very first repo, Caleb is an awesome teacher, I will leave him a nice review. And that matches what we have in here. Now, you might see something, and I'm going to set up an example here. You might see a strange thing happen when files on GitHub change, and so do your local files. And so what I mean here is that changed for a fourth time. That's all I'm going to say there. And so what I'm saying really is, let's say I don't have these latest changes. I don't have change for a fourth time on my computer. Let's demonstrate this. Git log -- one line. Not online, but one line. I don't have that latest one on my computer. It doesn't even know about it. So let's say that happens and I go and edit my file locally. Let's say this is a new line here. And let's say I want to push this up to GitHub. So git status, git add readme, git commit from local computer. That's my commit message. Commit git commit -m. Git push origin main. And this tells me a bunch of stuff. And this looks really alerting, but it actually isn't. If you ever see something like that, just read through this. It says, hint, updates were rejected because the remote contains work that you do not have locally. What that is saying is, github.com is remote. You are local, github.com is remote. So it's saying github.com has changes that you don't have on your computer yet. This is usually caused by another repository pushing to the same ref. That's a fancy way of saying there are changes on here that you don't have. And that could be from another repository, could be from another person. It could just be because we edited a file manually on here instead of doing it on our computer. You may want to first integrate the remote changes. Example, git pull before pushing again. See the notes about fast forwards in git push -- help. So now it's giving us things we can work with. Let's go ahead and do exactly what it says. Git pull origin main. It says git pull dot dot dot. That dot 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 is going to be our origin main. We always say git pull from, let's say GitHub. That's going to be our origin, and our branch name. That's going to be main. So git pull origin main. Now this says that there is a conflict in here, and for Git and GitHub 101, conflicts are beyond what we're going to be learning. That's a little bit trickier to deal with, and I don't want to overwhelm you. So what we can do is we can say git status, and it tells us what we can and can't do. So it's trying to do a rebase here. So let's go ahead and do git rebase dash dash abort, git status, git log, and git status was just to show us that there's nothing in there. Git log. We are on from local computer. So what we can do is we can say git pull origin main dash dash rebase. And what this is going to do is it's going to pull in that work, and it's going to put our work on top of it. So basically it's going to say, instead of conflicting, we're going to say, hey, grab this stuff from GitHub, and then whatever happened after that, put our changes on top of it. And this actually didn't work for me the way I was expecting it to work. Usually this does work. And so there is a conflict in here. Let's go ahead and, you know what? Let's resolve this conflict in the next video. Okay, let's go ahead and resolve this conflict. So we are trying to pull in changes from GitHub, and we have changes on in the same file on our computer. And so when we do, let's first of all clear this off. Git status. It says there's a rebase in progress, and you are currently rebasing branch main on a commit hash. Fix conflicts and then run git rebase dash dash continue. Use git rebase dash dash skip to skip this patch, or dash dash abort to skip. So if you're ever like, ooh, I really messed up and I don't know what I'm doing and I'm scared, you can always just type git rebase dash dash abort, and that will stop all of this for you and revert back to normal, and then you can ask someone for a little bit of help. So let's go ahead and say git diff readme, nope, readme.md. And it says a bunch of stuff in here. And it's all green. So let's go ahead and open up VS Code. And VS Code, I'm using the Git extension in VS Code, so it automatically shows me what is coming in and what is the current change. And so up here, this is what GitHub has. GitHub has Caleb is an awesome teacher. I will leave him a nice review. Files on GitHub change, so do your local files. I don't remember what I was trying to say when I wrote that. But let's say, for instance, I wanted to merge this together. Well, what GitHub is going to do is it's going to add all these little arrows, head, bunch of equal signs, and then more arrows, and that's going to tell you that the top is GitHub, the bottom is from your computer. And so what I can do is simply just delete these lines. Delete these lines. And so this is the code. This is what it looks like. This looks a little more, well, it looks less overwhelming. And this says, Caleb is an awesome teacher, yada, yada, yada. Let's say I want to keep that line, and I want to delete that middle line and keep this bottom line. Okay, so I'm going to do that. I just save that file. I just edit it to be exactly what I want it to be, and I save that file. Let's go ahead and do a git status. We can do git diff readme.md again, and this looks a little more recognizable. It doesn't have all those weird arrows and equal signs in there. If we do git status, it's going to tell us what to do. So we need to use git add file to mark the resolution. So we have resolved that conflict. So we do git add and then that file. And then to continue with the rebase, we do git rebase dash dash continue. So git rebase dash dash continue. Let's do git log dash dash one line. And now we can see that we are from local computer, we're one step ahead of where GitHub is. And so if we look at our file on our computer, it says Caleb is an awesome teacher, yada, yada, yada. This is a new line here. And if we go over to github.com, in our readme.md, it doesn't have that line yet. It doesn't have this is a new line here. we haven't added that. We need to add that still. So what we can do is push this code. So git push origin main and that was successful. So if we do git log -- one line, we're going to be able to see that origin head is exactly where our head is at. And it's saying from local computer. So if I refresh this, this line here should say from local computer. This line should say 6 commits. And there should be a new line down at the bottom of the README. Let's refresh. There's that new line. There's that from local computer. There is the 6th commit. We have now just resolved a conflict. That is actually a pretty advanced thing for us to do. I was hoping we could get away without doing that in Git and GitHub 101, but that's okay. We would have had to eventually tackle that regardless, so it's good that it came up. Okay, let's talk about your project. Your project, and this is very, very important. First of all, if you don't have a GitHub account, create a free github.com account. If you don't have Git on your computer, install Git. That's very, very important. Then I want you to create a new repository on github.com. Pull your repo from github.com to your computer. Edit a file on your computer. Push that file to github.com. Remember, you're going to need to use commit, and you're going to want to use git status a lot. And lastly, take a screenshot of your GitHub repo and share it with the class. And so that's really all I want you to do. Now this sounds like it's going to be a lot. You should already have a free GitHub account. If you don't, that's going to take you a minute. If you don't have Git, that should take you about 5 minutes to install. You can create a brand new repository on github.com. That's only going to take you about a minute. Pull your repo from github.com to your computer. There's a little bit of intricacy in here, so you're going to need to open up Terminal or Command or PowerShell or whatever program you want to use. You just need some sort of command line program, and then you want to run git clone, and then whatever that link was, https github.com/CalebTallien/test repository.git. I think that was the link. So you're going to want to run something like that, but it's going to be your account and then your repository name.git. So you're going to want to make sure you run that on yours, not on mine. You want to do it on your repository in your account. Then edit a file on your computer. Stage and push that file, stage, commit, and push that file to github.com. And take a screenshot of your GitHub repo with the new commit in there, the new file that you added, and share it with the class. That's it. So all in all, this should only take you about 25-30 minutes. And don't forget, if you have questions, you can ask them down below, or you can ask questions in the Learning to Code Facebook group. I am always there to help people with questions.